Good day. Today I shall introduce derivatives of trigonometric functions. And here they are, all over here. I would personally suggest that everyone tries to memorize these ones for sure. Some professors, some teachers who are a bit more cruel are also going to make you memorize these ones. But they're not too bad, right? So the derivative of sine is just cos. The derivative of cos is just negative sine. The derivative of tangent is just secant squared. For these guys, I personally actually never memorized them. I just always used formula sheets. And in fact, if you know these, you can figure these ones out as well using different techniques, right? Because of course, cotangent is just 1 over tangent, and so on. So let me just go through a couple of examples here. Hopefully you'll make great sense to everyone. And once you're done these, you can go to our website, and if you're not already there, you can try some questions. None of these will involve the chain rule, by the way. But on our website, we're going to have quite a few that will, indeed, also involve the chain rule. So let me take the derivative of question number 1 here. So y equals 3 sine x plus 1. So dy dx will be equal to d dx of 3 sine x plus 1. And what I'll do here, of course, is that I can essentially just, well, I gave myself very little space to do things here. Very little room. It's too bad. I can just do this, can't I? I can just take out a 3 here, because that's just a constant, and take the derivative of sine of x. And the derivative of a constant, which is 1, is just 0, so I don't even really need to write it. Okay? So that's going to be quite straightforward. We just have dy dx is then equal to 3 times the derivative of sine of x. And we come up here, we know that that's going to be cos of x. So we get dy dx is 3 cos x. Great. Fantastic. Now how about number 2? Let me try to change the colors here so that it doesn't get too confusing. So y equals, or, well, I'll just go for dy dx already, of d dx cos x plus 5. Oh, no, negative cos x plus 5. Almost messed that up. So, very similar to the previous question, I can actually just take out the negative outside of the d dx. So I get cos x. And again, the derivative of a constant is just 0, so I don't really need to bother with it. So I get dy dx is equal to, now the derivative of cosine is just negative sine. So I get, but I have another negative waiting outside here. So dy dx of negative sine of x will be just positive sine of x. Fantastic. Then, how about question number 3? I'm running out of different colors. Pick green, I think. Here we go. Great, so I got dy dx is equal to d dx of 10x. Now, 2 over cos, remember that 1 over cos is just what? It's secant, right? So I can rewrite this as 2 secant of x. And so dy dx is going to be, I can just rewrite this whole thing as d dx of 10x plus 2 d dx of secant of x. So, piece of cake. We just have to go to the little formula sheet here, or the table, and d dx of 10 is just secant squared. And 2 times the derivative of secant is just 2 times the secant and 10. So we get 2 times secant, whoops, x 10x. That's it. Because that was... These ones are a little bit more interesting, right? The derivative of secant of x is actually secant times tangent. So 2 times that is what we get over here. And I gave myself no space to do the last one, but that's okay because it's not a particularly challenging problem. Let me just try to pick a different color here. Okay, okay. So we got now dy dx. I'm gonna have to erase some stuff. There we go. So dy dx of this will be, the derivative will be d dx of 2 pi cosecant x plus, this I will rewrite as cotangent because that's going to be a bit more straightforward. We have the formula right here. The derivative of cotangent is just negative cosecant. Fantastic, isn't it? So I can rewrite this first as, now 2 pi is just a constant, which I can remove from inside the derivative. So I have 2 pi d dx cosecant plus derivative of cotangent, which we know already that will be negative cosecant squared. So 2 pi times the derivative of cosecant, which is negative cosecant cotangent, multiplied by 2 pi, I get negative 2 pi cosecant of x cotangent of x plus, now the derivative of cotangent, like I mentioned before, is just negative cosecant squared. So I can just write minus cosecant, whoops, squared of x. That's it. Now, of course, I recommend you should try around 100 problems. For practice, you can visit our website and check them out. Good luck.